So today is all about sine and cosine graphs. What we're going to do first is we're going to go over the parent functions, sine and cosine graphs. These are functions that haven't been transformed at all. So today is about sine and cosine. Next class is about tangent and cotangent. The class after that is about cosecant and secant. So first, we're going to take a look at the parent sine function. Notice that our graph, our equation, is just y equals the sine of theta. This is as bare bones as we can get for this sine graph. Now, first thing we're going to do is we're going to look at these dotted lines. Now these, like it says, these dotted lines are not part of the graph. They're just kind of like imaginary lines that help us graph this function. Now what you're going to do is you're going to draw a line representing the y-axis somewhere over to the left here. And this center line we're going to treat as our x-axis. So this is our x, this is our y. And this center x line, that y value for that line is 0. So we're just going to put a 0 right there. And then the top dotted line represents a y value of 1. And the bottom dotted line represents a y value of -1. And then in this class, it's kind of nice. The advanced class had to graph the sine function using radians. We're going to graph it in degrees, which makes it a little bit easier for us. So instead of doing radians, we're going to do degrees, and we're going to do the 4 main angles on the unit circle. So the 0-degree angle, which is the y-axis basically right here. Then we're going to do the 90-degree angle, the 180-degree angle, the 270-degree angle, and the 360-degree angle, all equally spaced apart. I didn't equally space them, but that's because I, for some reason, am not very symmetrical today, so I'm sorry for that. Okay, now, this is where our unit circle comes in handy, because if I'm trying to graph sine of theta, that's sine of my angle, on my unit circle, sine was which value in our coordinate point? Yeah, it's our y value, where x was our cosine. So on this graph, all I'm concerning myself with are the y values of the coordinate points. So if I'm looking at my unit circle, which I guess I could pull it up. So the first thing I want to graph, that first tick mark I drew, was the 0-degree angle. What is our sine value for the 0-degree angle? Remember, sine was the y value. Yes. So the 0-degree angle has a sine value of 0, meaning in our notes for the 0-degree angle, which is that first tick mark on the y-axis I drew, the sine value is also 0. So that's my first point. Next, the next angle I'm trying to graph is 90 degrees. So if I'm looking, my 90-degree angle has a sine value of what? 1. Yeah, good job, Lauren. 1. Meaning, for that 90-degree tick mark, I'm plotting a point that has a y value of 1. Then on to 180. 180 has a sine value of Yes, 0. Yes, yes, yes. If we're looking at the 180-degree angle, 0 is my y value. So 0 is my sine value. So 180 has a y value of 0. And 270 has a sine value of, yeah, -1. Lauren, guys, Josh and Lauren, stop. 270 has a y value of -1. And lastly, 360. 360 has a sine value of, yes, 0. So connecting these points creates what is referred to as a sine wave. This is a sine wave. This is a sine graph, fondly referred to as a sine wave. Now notice that this being a single sine wave means that this wave actually repeats over and over and over again. It goes on infinitely because that is what a circle does, right? We can go around the circle as many times as we want. It goes forever, just like the sine wave goes on forever. But this is just a single sine wave, starting at 0, 0, going up, going down, and then going back to the middle. And also notice that the entire length of this single sine wave is 360 degrees. This length of a wave is referred to as the period. And in this case, the period length is 360 degrees. Period is the length of a single wave. Okay. My nose is really like runny today in this mask. Okay. I can't go over very far. There we go. So now we're going to graph cosine. And we're going to start the exact same way. We're going to draw a line that represents our y-axis over here to the left. This is our y-axis. And then we're going to treat this center dotted line as our x-axis because our parent function is centered on the x-axis. And we're going to draw the exact same tick marks of 0, 90, 180, 270, and 360. And the y value of the x-axis is 0. The top dotted line is still a y value of 1. And the bottom dotted line is a y value of -1. So now we're going to do the exact same process, the exact same thing. We're going to look at our unit circle, and we're first trying to find the cosine value of the 0-degree angle. Remembering that cosine is the x of the coordinate point. So here, what is the cosine value of the 0-degree angle? 1. Yes, so we graph the 0-degree angle has a y value or a cosine value of 1. So that's the point we graph first. So notice it's already different than sine. Instead of starting at 0, 0, we're starting at 0, 1. What about 90? What is the cosine value of 90? Yes. Up top, that 90-degree angle has an x value of 0, meaning meaning the cosine value is 0. And then onto 180 degrees. What is the cosine value at 180? Yeah, -1. Oh, I keep doing that. I'm so sorry, guys. Let me do that. And 270 has a cosine value of 0. So we go back to 0. And then lastly, 360 has a cosine value of 1. Yes. So this is the parent function for cosine. Oh my gosh, that's an awful graph. Like I said, I'm struggling on being symmetric today. Nope, didn't make it any better. We're gonna stick with it. So notice again, cosine starts at the top of the wave and ends at the top of the wave, versus sine starting at the middle of the wave and ending in the middle. You kind of need to remember this pattern in order to know the difference between these two waves. You need to recognize that sine starts in the middle, goes to the top, goes back to the middle, goes to the bottom, back to the middle. Or we can write, if you're one to like acronyms or you're one to like to look at patterns, we can say that this first starting point starts at the middle, then we go to the top, then we go back to the middle, then we go to the bottom, then we go to the middle. So our pattern is MTMBM. Versus the pattern for cosine is we start at the top, go to the middle, go to the bottom, go to the middle, and go to the top. Also notice our period length is still 360 degrees. Remember, period is the length of a full wave. So our period is still 360. Which is what this little first asterisk says right below. It says the sine and cosine graphs make one full cycle in 360 degrees, or 2 pi radians. Also, you might notice that if you were to continue drawing the cosine graph, do you notice something about cosine? They're what? Oh, I think I see what you're saying. If I continue drawing the cosine graph, you notice that it is actually forming the exact same shape as sine, right? It's forming the exact same wave. The only difference between sine and cosine is that they're 90 degrees shifted from one another. Below here is just a whole bunch of properties. We're not going to read through them because basically I talk through them when I'm doing these notes. But if you ever want to come back and know, okay, how do I find domain and range? How do I know what the period is? Or how do you know the x-intercepts? Or how do you know the min and max? All of that info can be found in these two tables here. All right, so now we're going to go over transformations, which is the exact same thing that we have been doing every single parent function. Every single function that we've looked at so far has the exact same transformations that could be applied with A, B, H, and K. They are the exact same letters, the exact same variables that they have been since the start of Algebra 2. Now, just so I can reference back, or so that you can see, if we were instead dealing with a quadratic, this is what the transformation function looks like when we have a quadratic. With A being our vertical stretch or compression, B being our horizontal stretch or compression, H being our translation left and right, and K being our translation up or down. The letters are still exactly the same. The only difference is they kind of have different vocabulary for A and H. There's different vocabulary. They're called different things now. So what I mean by this is that A, we're no longer calling our vertical stretch or compression. Instead, we're calling it our amplitude. We call it our amplitude. Now the amplitude is just the height from the center line to the maximum of the graph. So if I'm looking up here at my parent function, the height from the center line to my maximum is just 1. What this means is my A value, or my amplitude, is 1. And that makes sense, right? Because there is no number in front of my sign, meaning that your A value here is 1. So you could have gotten it from the equation, but you can also see it on the graph by looking at the distance from the center line to the maximum. Okay, so that's what A does. A changes the height. A changes the height of the graph. B is our horizontal stretch or compression. Now on the graph, if I'm stretching or compressing on the horizontal, what it's doing is changing the period, the length of a wave, right? If I were to horizontally compress, I would be taking this last point, this 360-degree point, and I'd be squishing it inward, making this graph shorter. So it would actually be changing the period length. B affects the period. So that's why it's called the period constant. It changes the period length, the length of a single wave. Now how you find the period is by taking 360 and dividing it by your B value. So if I had, for example, sine of 2x, the 2 is my B value. The period for this example, which period is always for some reason denoted with a capital T, the period length would be 360 divided by 2, or 180. So that's how long that graph would be, is 180 degrees. You use B to find the period. H is, remember, our horizontal translation, the shift left or right. They now call it the phase shift. It's a phase shift. So H still behaves the exact same way. It still just shifts the graph left or right, but it's now called your phase shift. And K is still the exact same. It's our vertical shift. It's what shifts us up or down. It's what shifts us up or down. And H is what shifts us left or right. And like I was saying before, the period is the length of a full cycle, and it can be found by taking 360 divided by your B value. And also, you can break each one of these graphs up into 4 increments. You can break it up into 4 increments, and you can find these increments by taking your period divided by 4. So what this means is if I'm working with this same example and I'm trying to find what tick marks to put on my graph, I know that my full period length is 180, right? That's where I'm stopping. But to find the in-between points, what you do is you take your period and divide it by 4. So 180 divided by 4 is actually 45, meaning that your first tick mark is at 45, your second tick mark is at 45 plus 45, 90, and your third tick mark is at 90 plus 45, 135. Any questions? Now all of this was just vocabulary. I know that a lot of this like kind of went over your head right now, which is fine. I just had to tell you it so that you understood what I was talking about when we do these examples. Okay? So if you're feeling like totally overrun right now, like you have no idea what just happened, you're not alone. I'm sure most of you feel that way. All right. So now let's actually get into these examples, right? I don't know about you, but I learn best from examples. I don't really learn best from people just telling me things, which is funny because I'm a teacher. I think it's funny. All right. On this first example, now this is as easy as this can get. Besides the parent function, this is the easiest graph that you can see. You're going to follow these exact same steps every single time you go to graph one of these functions. First, you're going to identify A, B, H, and K. Those are like your cornerstones, the most important parts of your graph. A, B, H, and K. So on this graph, what is our A value? Yes. Our A value on this example is the number in front of your function. So your A value is 3. And remember, A is your amplitude as well. So that's like the height from the center of your wave to the maximum point. What is your B value? Hmm. Remember, B is the variable right, or the number right in front of the X. So is there a number right now directly in front of our X? No. So there's actually an invisible what? 1. Our B value here is 1. 1, 1, 1. What's our H? What's our H value? Do we have an H? Is there a number after the X? No, you're right. It is 0. It's 0. And what about K? Is there a number way after the X? No. So again, K is 0. Okay. So before we start, I know that this tells you these steps 1 through 6. However, I am going to tell you what steps I would do. First, I like to find everything that needs to be found first. Meaning, I'm not just going to go and graph this already. What I'm going to do is I know that once I find A, B, H, and K, I need to find a couple of other things as well. I need to find my period. which is that capital T I was talking about. How do you find the period? Right, you take 360 and you divide it by your B value. And in this case, our B value is 1. So our period length is just 360 degrees. There's also one more thing I need to find, and it is what is called your tick mark width. Which is just the distance between your tick marks. This was on the previous page what we called the increments, the tick mark increments. So here, to find your tick marks, what you do is you take the period and you divide it by 4. So 360 divided by 4 is 90. Yes, Peyton. So now actually, I have everything I need to graph this. There's nothing I need to solve for, nothing else I need to find. I'm good. So now we're going to do what these steps tell us. We already drew, it says draw 3 dashed lines. We've already drawn them. The max, the center, and the min. Then we're going to label the center line with our K value. Always the center line is going to be our K value. Now here, because the K value is 0, it means that the center line is 0. And then what you do is you use your amplitude to label the max and the min, because the amplitude is the height from the center line to the max. So if my amplitude is 3, what number am I going to put on that top dotted line? Yeah, right? The distance between the center line and the top is 3. What am I going to put on the bottom line? Yeah, the exact opposite, -3. And then what you're going to do is you're going to place your tick marks on the graph. Now, your starting tick mark is always actually located at your H value. So here, because my H is 0, my first tick mark will also be 0. Then you use your tick mark width to get the rest. So if my width between tick marks is 90 degrees, from 0 to the next tick mark is 90 degrees, meaning the next tick mark has to be 90. And then what you do is you keep adding the tick mark width. So the next tick mark after 90 is 90 plus 90, 180. The next tick mark after that is 180 plus 90, 270. And the next tick marker after that is 270 plus 90, 360. Now we know that we need to stop at 360 because that is our period length. That's the length of a full wave. All you're ever going to draw is these 5 tick marks with different numbers on them. And then I know this is a sine graph. And sine has the pattern middle, top, middle, bottom, middle. So I'm going to plot those points. Middle, top, middle, bottom, middle. Connect the points. Draw your x and y axis. So my y-axis is through 0, my x-axis is through 0, and you're done. Are there any questions on what I did on this graph? All right, so now we're going to do example 2. Now, in these next upcoming problems, we have so nicely created this table for you. This table is just a really nice way to organize everything that you need to find before graphing. So everything that we did in this example 1 over to the side and on this graph, we just nicely are going to organize in this table. We're still doing the exact same process. First, we have to identify A, B, H, and K. What is our A value in this example? One half, good. Actually, I forgot. I want to change this problem a little bit to make it just a tad bit different. I'm going to have it be, instead of a sine, I'm going to have it be cosine. And also, I'm going to give it a K value of 4. All right. I forgot. I wanted to change that. So our A value is 1/2, which means what else is a half? What does the A value determine? Our new vocab word. Yes, the amplitude. So here for amplitude, I'm going to write a half. What is our B value? Yes. Now, what does the B value affect? What new vocab word did I say? Yes, the period. The B value affects the period because you find the period by taking 360 and dividing it by your B value. So in this case, if our B value is 2, what is 360 divided by 2? Yes, so in this problem, our period length is now instead 180. Meaning, if I was thinking about the parent graph, I am horizontally compressing it to all fit inside of 180 degrees instead of the full 360. What is our H value? So remember, the number right in front of the x is B. The number directly after the x would be our H. Yes, so here our H value is 0. There isn't a number right after the x inside of the parentheses. So our H value is 0. What about our K value? Let's do red. No, let's do blue. Yes, the K is the number way at the end, is 4. Is 4. So now, the only other things I have to find are all of my tick marks on the x-axis, on the center line, I should say. Now, who remembers, how do you find the tick mark width? The distance between tick marks. Period divided by, not 2, 4. Yes. Period divided by 4. So I'm going to say period divided by 4 gives me the tick mark width. So here, my period is 180 divided by 4 is 45 degrees. Now I know that I've thrown a lot of info at you today, but does anyone remember where I said the first tick mark will always start? Why 0 in this case, Abby, or anyone? Why is it 0 in this case? Because what is 0? Right. You always start on your H value as your first tick mark. So here, because we don't have an H, the H is 0, our first tick mark will start at 0. And then to get the other tick marks, all you have to do is take the previous tick mark and add the tick mark width. We'll use blue. So here, my second tick mark is at 45. Then for my third tick mark, you take the previous tick mark 45 and add another 45. Whoops. I want to be trying to be consistent with color here. And you get 90. And then you take 90 and you add the tick mark width again. 90 plus 45 is 135. And you take 135 and add the tick mark width. And you get 180. Which the distance between your first tick mark and your last tick mark should be the length of the period. Which in our case, the distance between the first tick mark and the last tick mark is 180, which yes, is our period. So that's how you can check to see if you found the tick marks correctly. The length of the full wave is the period. So these two numbers should match. What the heck was I about to write? Watch should match. Whew. So there's a lot of there's a lot of stuff, pre-knowledge, that we have to find before we can graph, which once we've organized it and found it all, it's super easy to then apply it to a graph. So the first thing that I always do is I write down the value of the center line, which the value of the center line, the number, is always our what value? So that's where our first tick mark is, Sydney. Our first tick mark is 0. But what is the y value of the dotted middle line? What is the y value of the dotted middle line? Ooh, should I just tell you, or should I go up here? Where, so this is the number I'm trying to write down first. Where did we get in this previous example? Yes, the k value. The value, the y value of the center line is always your k value. I'm going to erase this because it's getting in our way. I'm sorry. I just want it to be super clear that the center line is always your k value. And then you're going to write down the y value of the top dotted line and the y value of the bottom dotted line. How do you get these values? Right, you use the amplitude, yes. So what you need to do is you need to ask yourself, we need to add a half to 4 to get the top dotted line value. So what should I write here as my top dotted line y value? Right, 4.5. And what is the value of the bottom line? Oh, I'm getting cramped sitting here. Yes, 3.5. It's the center line minus the amplitude. And what I'm just preemptively going to do here is I'm just going to draw a line for my y-axis. And then what I'm going to do is I'm going to write down the rest of my tick marks. So I already have the tick mark for 0. Now I'm going to write down the next tick mark, 45. Then the next tick mark, 90. The next tick mark, 135. And the next tick mark, 180. Now this is a cosine graph we changed it to. So my pattern, we have to remember for cosine graphs, is top, middle, bottom, middle, top. So what this means is I place a point on my top dotted line, I place a point on my middle dotted line, I place a point on my bottom dotted line, I place a point on my middle dotted line, and I place a point on my top dotted line. Connect the points, and you're done. The only other thing that they might ask you to do, or that we should do, is draw the y-axis. I'm sorry, we already drew the y-axis. Is draw the x-axis, but the x-axis is way down below. We really can't draw it. It's off our graph. So we're not going to bother drawing the x-axis. Are there any questions on this graph?